Hi people, quick one. I have using Cramer's rule in matrix to solve simultaneous equation. Uh, First and foremost, what is matrix? Matrix has to do with mathematical array of numbers arranged in rows and columns. At this point, all I need to do is apply this Cramer's rule in getting this simultaneous what equation. Of course, simultaneous equation can be gotten using elimination methods, even graphical method, or even substitution method. But with the idea of matrix, we can also get this using what? The Cramer's rule. Remember, Cramer's, not Cramer's. So at this point, I will use Cramer's rule to get this solution. Probably subsequent videos, I'll also use the inverse method. Here we go. Remember, in Cramer's rule, we need to take note that x is equal to the determinant of change in x over determinant of change. That is what Cramer's rule gives us when we are talking about the value of x. Then that of y, we must also take cognizance that in y value, talking about this Cramer's rule, we will know that the determinant of change in y will be divided by determinant of what? Change. So by the time we pick out the value of the change, get the determinant, then we need to obtain the value of change in x, then get the determinant, we divide the value, then that gives us the value of x. The same way we approach it in the value of y. Here we go. The very first thing we need to do is to write out the value of change. How do you get the value of change in this equation? You must look out for the coefficients of these values. We have 3, we have 2, we have 4, then we have minus 1. These are the coefficients of the variables given. So the first thing, we need to align it the way it is. The value of 3, then that of 4, then positive value of 2, then negative value of 1. That is minus 1. So this becomes the change. But remember, this same change, we need to obtain the determinant of change. How do you get the determinant of change? We have it written in this manner. This becomes determinant of change becomes equal to, how do you get the determinant? Remember, you need to focus on the leading diagonal. And the leading diagonal is what? 3 and what? Minus 1. So by the time you multiply the leading diagonal, a minor diagonal. So this becomes 3 times negative value of 1, then minus what? 2 times 4. So there we can now deduce that the determinant of change becomes 3 times minus 1 is what? Minus 3. 2 times 4 is what? 8. So minus 3 minus 8 is what? Minus 11. Sorry, I needed to show it step by step, but we are trying to manage the board. So the determinant of change becomes what? Minus 11. Take note, we need to obtain the change in x. Our change in x will be equal to, in this change in x, we need to take a close look at this equation. Where can we find the value of x and its coefficients? You can see them, 3x and that of 4x. So at this point, we need to cover it. By the time you cover the value of x and its coefficients, then you replace it with the result. 12 and that of 5 will take the place of what? X, because we are looking for the change in x. So what we have at this point becomes 12, then that of 5. Then we continue with the one we can see, which is what? 2. Remember, we are writing only the coefficient. That is the number that multiplies the letter. So here is minus y. Of course, the coefficient becomes what? Minus 1. You have your minus 1 here. Then you close it. So this becomes the change in x. But we also need to get the value of determinant of change in x. So we have our change as what? This. You can see our row, you can see our column. So right here we obtain the what? The determinant of change. Here we have the change in x. Then we need to obtain the determinant of change in x. That becomes the determinant of change in x. Of course, you should be conversant with how determinant is what obtained, which I've done right here. Then you need to multiply the what leading diagonal. What is the leading diagonal? The leading diagonal is the one of top left corner times what? The bottom right corner. So that is 12 times minus 1. What do you get? Minus 12. Then minus. Then the minor diagonal, 2 times 5, you get what? Of course, 10. So we are having minus 10. We can now say that determinant of change in x will be equal to minus 12 minus 10 is what? Minus 22. So this is the determinant of change in x. The next is what? The value of y. What becomes the change in y? Change in y will be equal to the same approach. If you get where y is, you cover it. And when it is covered, it will be replaced with the result gotten, which will have them as 12 and 5. They will take the place of what? Y. Then what can we see here? 3, 4, 12, and what? 5. Of course, 3 and 4 come first. So we impute it into the value. This becomes, let me still close that, 3 and that of 4. 3, 4. Then we have 12 and 5 in place of what? The y values. 12 and that of 5. This is the change in y. What is the next step? The next step is to obtain the determinant of change in y. Doing that, we have determinant of change in y will be equal to what is the leading diagonal? The leading diagonal is what? 3, 5. So this becomes 3 times 5. You get what? 15. You write it down. Then put your minus. The minor diagonal, you have 12 times 4, which is what? 48. We're having minus 48. So 15 minus 48 is what? Minus 33. We can now say that determinant of change in y will be equal to minus 33. Obviously, every value here has been treated. Now let us apply the Cramer's formula, which says that x is what? Equal to determinant of change in x over change. So if x is equal to determinant of change in x over what? Determinant of change. Then what is determinant of change in x? The determinant of change in x is what? Minus 22. We plug it into the equation. That's minus 22 over what is the determinant of change? Determinant of change is what? Minus 11. We have minus 11. Of course, minus cancels minus. 22 divided by 11 is what? 2. So we can deduce that the value of x here is what? 2. X is equal to 2. That is how we obtain the value of x. The same way, what about y? Of course, y gives us what? The determinant of change in y over the determinant of change. So this becomes y to be equal to the determinant of change in y divided by what? The determinant of change. So what is our determinant of change in y? The determinant of change in y becomes minus 33. Minus 33. Then divided by, what is the determinant of change? The determinant of change here is what? Minus 11. Minus cancels minus. So y becomes what? 3. Yes, now. 3 divided by 11 is what? 3. So in this equation, the value of x is what? 2. And the value of y is what? 3. You can also run your check. If x is what? 2, 3 times 2 is what? 6. If y is what? 3. 2 times 3 is what? 6. So 6 plus 6 is 12. Here, second equation. If x is what? 2 and y is what? 3. So 4 times 2 is what? 8. 8 minus 3 is what? 5. So ladies and gentlemen, this is how Cramer's rule is applied in matrix. Okay, maybe subsequent videos I will use the inverse rule in matrix. Bye bye. Please like, comment, and share. Thank you.